Hello, in this video, we are going to understand better what a significance of regression is and what a residual is, because we are going to use residuals to test assumptions of regression in later videos. Okay, so let's get started with a generic multiple linear regression line one more time. So we saw this earlier, but let me remind you one more time that we do have a multiple linear regression model when we do have more than one independent variables. In this case, we do have k different x independent variables, and we do have the coefficients as represented b's, and we do have an intercept in this model as represented as a. And y on this case is going to be our fitted or predicted dependent variable. It is important to get the concepts right because we are going to keep referring to these terms in later videos. So make sure that you understand when I say fitted, why you understand that it is an output of this multiple linear regression function. Okay, so what do we do? I mean, we do, by running multiple linear regression, we do try to fit a value for intercept A and these coefficient B's, right, for independent variables. And we would like to see if a specific independent variable is statistically impacting the changes in the fitted value. So how do we do that? I mean, we do run several tests behind the scene, actually. When you type lm in function, the linear equation in R, and hit Control and Enter, well, it actually runs several hypothesis tests. So this video is going to be a quick look into what those hypothesis tests are and how do we use them. All right, so the first one, I'm going to explain those over the Bandrix data. They're going to re-import it, and you can see everything that I typed here in multiple linear regression part 2 R file. Let's get started with that. So if you go ahead and download multiple linear regression part 2 R file, you will see this code. And at the very top, I say that we should import the Bandrix dataset, right? So go ahead, import Bandrix dataset from Excel. I do locate it here. This is my chapter, so let's go back. This is module 3, obviously, and the Bandrix data. Okay, we imported it. We used this data set earlier. If you remember, we are trying to predict what's going on in the overhead cost by using machine hours and production runs. Okay, and let's fit a regression model. We called it LM4. It was referred to as LM4 in multiple linear regression R file. Previously, we used it in module 2. And let's recreate this. So as you can see, all we need is the LM function, and overhead is going to be represented or defined as function of machine hours and production runs. Remember, this tilde operation helps us do this, help us set up this kind of relationship. And our data is from the Bandrix dataset, right? We just imported it. And let's run this. I hit comment and return, and to retrieve the results of this regression, you need to call this in summary function. All right, so we do have these results. So the Excel file, sorry, the PDF presentation here is going to highlight these areas over these results, okay? We're going to come to these residuals later on, but let me talk about what you see here in very detail over this presentation. Okay, so the first value that you need to look at when you get the result of a regression, like in this case, is the significance of regression. Significance of regression is represented here at the very bottom. Don't look at these p-values. These p-values are for independent variables, okay? But the p-value that you see on the very bottom is the p-value for testing the significance of regression. Well, what are we testing when I say significance of regression? It is a hypothesis test, and it claims that in the null hypothesis, it claims that it is the status quo. Remember, it is the current case. It claims that all the coefficients, in this case, I do have 2 coefficients, right? If you have more than 2 independent variables, significance of regression in the null hypothesis, it stands for all the intercepts are equal to 0. What does this mean? Well, it means that neither machine hours nor production runs explains the variation in overhead costs. Remember, we challenged the status quo. In the alternative hypothesis test, it claims that there is at least one B, one coefficient in this regression that is not equal to 0. And if a coefficient is not equals to 0, then what does that mean? It means that a coefficient should be in the equation, and it means that it should be used to explain the change in the fitted y value. Okay, so that is what we are going to do with this p-value. This p-value is going to be used to decide whether there is any independent variable, we don't know which one, that is going to be used to explain the change in the dependent variable. So in this case, this is a very small number, e to the power of minus 15 times 3.754. This is less than 0.05, our default level of significance. Therefore, I reject the null hypothesis. And null hypothesis here is H0. It indicates that all coefficients of this regression are equal to 0. In other words, it means that there are no independent variables that's going to be used to explain why. I reject that in favor of H1. My H1 says that there is at least one B that is not equal to 0. But the problem is which B that should not equal to 0. Is it one of them, or is it both of them? If it is one of them, which one is it? Well, in that case, the question boils down to looking at these p-values, okay? The p-values that you see in this ANOVA table, analysis of variance table. Remember, these are the estimates that we use to set up the linear regression equation, like in this case. Since this p-value is less than our level of significance, this passed the significance test, right? We could use this regression equation. That's what it means. And in this case, it suggests that I should use these estimates, these coefficients for intercept, machine hours, and production runs. But since I rejected my null hypothesis here and I claim that there is at least one B that should not be equal to 0, which B's are going to be statistically significant when you try to make that decision, you look at these p-values. And as you can see, these p-values are also very small. Machine hours and production runs p-values are all less than 0.05. And therefore, we say that machine hours and production runs are both statistically significant when explaining the overhead runs. So this is a quick summary and quick refreshment on your minds how multiple linear regression works.